Question 1. Function of fx equals x plus 2, 1 factor, x minus 1 squared, 3 factors altogether. Sketch the graph of y equals fx and identify coordinates. Now this can be written as x plus 2, that's the factor here, x minus 1, and I need to set these 3 factors to 0. Now that I've set it to 0, I set x plus 2 equal to 0, therefore x equals minus 2, taking minus 2 from both sides, and that's x equals minus 2. X equals 1 and x equals 1. So these are the roots. I need the roots to sketch my graph. I can find the y-intercept. The y-intercept, that means where it crosses y-axis when x is 0. So when x is 0 here, 0 and 0 there, so that'll be 2 times minus 1 squared. 2 times minus 1 squared is 1, 2 times 1 is 2. So the y-intercept will be 2. I would like to expand these factors now. So that's what I'm going to do next. So the first expansion I've done is x minus 1 squared. X times x is x squared. X times minus 1 is minus x. Minus 1 times x is another minus x. Minus x is minus 2x. Minus 1 times minus 1 is plus 1. So now I've got that. Now I'm multiplying this factor by this quadratic. X times x squared is x cubed. X times minus 2x is minus 2x squared. X times 1 is x. 2 times x squared is plus 2x squared. 2 times minus 2x is minus 4x. 2 times 1 is 2. So I'm simplifying these. X squared is that's x squared minus 2x squared plus 2x squared cancel out. Plus x minus 4x is minus 3x plus 2. So now I can see the intercept is y equals 2, and that's what we got earlier. I would like to find the maximum turning point here. The degree of polynomial is 3. That means it's got 2 turning points. The turning point is degree of polynomial minus 1. So that'll be 3 minus 1, so 2. So the turning point is 2. That means it's got maximum and minimum. And I need to find the coordinate of those. Okay, so what I've done here, this is the equation now. And I've decided to find the gradient. The gradient here is dy dx. That's how we write dy dx. And then I've differentiated that. That would be 3x, then 3 minus 1. So that's x squared minus, this is 3x. If I differentiate that, that's 1 and 1 times 3 is minus 3. And then 1 minus 1 is x to the power 0. X to the power 0 is 1, so we got 3. The formula I've used for differentiation, I'll write it here. So this is the formula I've used for dy dx. When y equals a x to the power of n, the y dx will be a n, so you bring the n down, x n minus 1. And that's what I've applied here. If you differentiate a constant, you get 0, because the constant itself is x to the power 0. X to the power 0, if you bring the 0 down, that will multiply by 2, that will become 0 times 2, that dismisses that one, that disappeared completely. At the turning point, the gradient will always be 0, because if there's a turning point here, that's a 0 gradient. This is positive, this is negative, so that's plus, negative, and that's 0. So that's why I'm setting that to 0. And therefore, I've taken a common factor out here, which is 3. X squared minus 1 equal to 0. If I divide both sides by 3, x squared equals 1. X equals 1 or x equals minus 1. One of them is maximum and the other is minimum. Now to sketch the graph. This is y-axis. The equation of the y-axis is x equals to 0. This is x-axis. The equation of the x-axis is y equal to 0. So these are the coordinates. These are the values of x, where the graph crosses the x-axis. These are the values of x. This is the y-intercept, y equals 2. One of these is maximum, the other is minimum. We'll find out in a minute. And we need to find actually the values of y for the x's. So what we need to do is put x equals 1 here and there. When x equals 1 in here, I get 3. When x equals 1 there, I get 0. So because 1 minus 1 is 0, 0 times 3 is 0. So when x equals 1, y equals to 0. Now I'm going to put x equals minus 1. So this is minus 1. Minus 1 plus 2 is 1. 2 squared is 4. 4 times 1 is 4. So for this one, y equals 4. For these roots, we know y equals to 0. Now we can plot these values. When x is 1, y is 0. That's 1 point. Again, another point. So we've got equal roots there. X is minus 2 when y is 0. So that's another root here. Then the next one is the y-intercept. When x is 0, y is 2. If I compare cubic here in terms of y equals ax cubed plus bx squared plus cx plus d. So if I'm comparing a cubic here, where a is positive, it will be coming from the third quadrant. So the graph will be coming up here, reaching a maximum, going back there. Because it's equal roots, so it will come in and it will live at the same point as well because it's equal roots, and then go up that way. When x is minus 1, we know y is 4. So that's the maximum, and the minimum will be here. So the graph will have a maximum here and a minimum here because the graph is coming from here, going all the way there, turning back down, and then turning there too, and the point of reflection will be here. This is a turning point here, so that's what I need to do first, and this is another turning point here. And so the graph will come down from there, and it will go up that way. Also, it will come from the negative y infinity. So the maximum point is that point there, and the minimum point is here. This is the intercept on the y-axis. So that's the minimum, and the coordinate is 1, 0, and this is the maximum, and the coordinate is minus 1, 4. This is the intercept on the y-axis, and the coordinate will be 0, 2. These are the roots here. So these roots are equal roots as well. So that's an equal root where you got x equals 1, y equal to 0 twice. And that's another root here where you have x equals minus 2 and y equals 0. Sketch the graph of y equals a half fx. So you're multiplying the whole function by a half. Right, so we know what fx is. The coordinates of fx are x equals minus 1, x equals 1, x equals 1, x equals minus 2, at y equals to 0. The maximum point was minus 1, 4, and the minimum point is 1 and 0. Now to find a half fx, that means we're not changing x. X stays the same, but what we're changing is y values. So the intercept will be affected. The intercept was y equals 2, so the intercept, y-intercept, is y equals 2. That will be affected. The maximum value 2 will be affected. 0 over 2 will not be affected, so it will still be 0. So the new coordinates here will be the same. All these will be the same. The maximum will be, you multiply 4 by a half, so that'll be minus 1 and 4 over 2, which is 2. For the minimum, you're going to get 1, and 0 divided by 2 is still 0. The intercept on the y-axis, because you're only changing the y values, so you're going to get y over 2, so that would be 1. So y equals 1. So now, to sketch the curve, when x is 1, y is 0. Now when x is minus 2, y is also 0. That's another point there. The maximum is minus 1, 2, rather than 4. So that will be the maximum there. The minimum will be 1 and 0. And the intercept on the y-axis will be, rather than 2, it will be 1. So now to sketch the graph, that's the turning point. And that's going down there. And this is another turning point. So that it's going up there. And that is just going there. Don't forget that that's the y-axis and the x-axis. And the equation of the y-axis is x equal to 0. And the equation of the x-axis is y equal to 0. Right, C part. Sketch the graph of y equals minus 2 f of x and identify the coordinates. Well, so we multiply now the whole function by minus 2. This is our f of x values. And now we're multiplying that values by minus 2. Again, we're changing y, we're not changing x. So this values is minus 2 now. So what we need to do is just the x will stay the same. If you multiply 2 by minus 2, you're going to get minus 4. So that will be at the intercept will be minus 4 there. The maximum will change because 4 times minus 2 is minus 8. So you're going to get minus 1, minus 8. The maximum will become the minimum because we're flipping this graph. And the minimum will become the maximum. And the maximum here will still be the same, 1, 0. So now to put the points in, when x is 1, y is 0. So we still have those points here. When x is 1, y is 0. When x is minus 2, y is still 0. The intercept is minus 4. And the maximum when x is minus 1, which is now a minimum, is going to be that. So that's the new minimum. And the maximum now will be 1, 0. So to sketch the curve, this is the new maximum. So we could just sketch that like that. And that's the new minimum. So we just sketch that like that. And this one is going to go through 4 to meet the maximum there. And that maximum will just go all the way. And this one will go all the way. And this will just go all the way to infinity, y infinity. And this will go to negative infinity. And the coordinates here will be 1, 0. The coordinate on the intercept here will be 0, minus 4. The minimum here will be minus 1, minus 8. And the coordinate here will be minus 2, 0.